Short liner repair of concrete sewer pipes with 3P resins in dry condition and underwater. Inflatable packers are the key tools for short liner pipe repairs. It is important that not only the high-quality resins and reinforcing materials, but also the high-quality packers are inevitable preconditions of a successful short liner repair. A good packer shows straight and center lines symmetric, and at a rough estimate barrel form under pressure. It means it can press out the water and the air in both directions from between the laminate and the original pipe. Old packers that have been used a lot may show asymmetry, irregular curves, and undulations under pressure. In this case, they are not suitable for the reliable pressing out of water and air and cannot provide uniform stress on the adhesion surface. There is a special equipment to measure the packer deformations under different pressures. Based on that, it can be assessed if the packer is still suitable for further high-quality work or not. Now let's go on to our main topic. How do 3P resins work underwater? If we can be sure that the packers are good enough. In the Nordic sewer pipe repair industry, it's always an advantage when a resin can harden under wet conditions, since there is always more or less moisture in the sewers. The worst case to simulate wet conditions is a position underwater. Now we test this case with a 2-component 3P resin. For the test, we lay a concrete pipe, diameter 200 mm, in a water tank. There are several types of 3PB components providing different pot life and viscosity values for the resin mix. Different B components can be mixed with each other to obtain the best fit to the customer demands. Component A is the same water-glass solution for all types. The mixing ratio of the E and B components is 1:2 by volume. Homogenizing usually runs with a mixing rod, installed to a drilling machine, speed 400 to 500 RPM. The mixing takes 1 minute. The reinforcement of the composite in pipe is usually a combination of 2 glass fiber layers, an oriented fabric and a felt made of fibers without orientation. The fabric layer provides the strength, while the felt layer keeps the resin in place and provides continuity for water sealing. The homogenized resin mix is poured on a foil-protected horizontal surface. The combined glass reinforcement is laid then into the resin and it is impregnated from below. The air can leave the system upwards easily, and therefore the hardened resin contains less air pores than the composites impregnated from the top. Using this impregnation method, water sealing and strength are both better than in the other case. The impregnated glass mat is folded into 3 parts, so that at the 2 outside lines there are only 2 glass layers. Therefore, the thickness of the composite will be lower at the edges. This form makes the composite pipe streamlined and decreases the axial forces arising at high-pressure water jet cleaning. The packer is covered by a thin foil for protection against the resin and for easy form release. The laminate is wrapped around the packer with an overlap. Finally, the laminate is fixed to the packer by rubber rings at both ends. In the practice, the workers deliver the packer into the sewer pipe through the nearest manhole, and its central part is positioned to the local damage using video camera control. Now in the test, the packer, which is installed with the rain-impregnated fibrous reinforcement, is simply put into the pipe, which we have laid under the water earlier. The packer is put under pressure. The necessary pressure level depends on the packer type. In this case, the applied pressure is gradually increased up to 2 bars. The time of hardening depends, among other factors, on the material of the repaired pipe, on the resin type, on the temperature, and on the amount of the resin. The heat which is needed for the hardening is produced by the resin itself by exothermic reaction. Since the water conducts much more heat away than air, the hardening time under water is at least 50% longer than in air, if all other conditions are the same. After hardening, the pressure is released, and thanks to the form release foil, the packer can be easily removed. The hardened composite pipe bridges over the cracks and seals the leakages as a pipe-in-pipe. We take out the repaired concrete pipe from the water for laboratory tests. The most important test is to measure the adhesion strength. It is important to know every resin type has different adhesion, which also differs for concrete, vitrified clay or PVC pipes. Beyond the good adhesion, 3P resins have a further advantage. They can absorb water just like polyamide. For 3P resins, this water absorption takes about 6 to 8% of the own mass. The swelling due to water uptake strains the inliner into the original pipe. This pre-stressing effect increases the resistance against the actual displacing forces of the high-pressure water jet and therefore helps the adhesion. To prepare the tests, after 2 days or later, the pipe is cut into 2 or 3 parts longitudinally, carefully with a diamond-reinforced steel disc under water cooling. It is important not to hurt the lining mechanically and also to avoid excessive warming and the separation of the lining from the pipe wall. Adhesion strength is measured by pull-off dollies. To fix the dollies to the lining, first their place is ground to plane for the actual diameter and then cut around by a crown driller. This way, the shear strength will not influence the measured results. The small circular test surfaces are roughened for better adhesion, and the dollies are glued on those with a high-strength adhesive. To remove any hardened glue that may flow or harden around the dolly, we cut it around carefully again later by the same crayon driller. Before testing, the full hardening of the glue must be completed. Usually it takes 1 day. The test method is the same for the specimens made in dry conditions and underwater. The pull-off test is carried out by a calibrated, displacement-controlled DEF-Fasco posi-test adhesion tester. According to the European regulations, the average value shall be at least 1.5 megapascal and the measured lowest value at least 1 megapascal. There is no standard adhesion requirement for repair underwater. First, let's see the adhesion test of a specimen made in dry conditions. It is also important to record the failure pattern. Did the glue separate from the lining, or the lining from the pipe, or the pipe material failed in itself? We cannot measure high adhesion values even with the best resins if the upper measurable limit is the own tensile strength of the concrete. This table shows the test results of the repairs made in dry conditions. Now let's see the adhesion strength results for our actual short liner test made underwater. There is no standard adhesion requirement for repair underwater. This table shows the test results for the short liners made underwater. Comparing the numbers in Table 2, we can see that the specimens made underwater but stored in dry and warm conditions between 25 and 30 degrees centigrade show substantially lower adhesion than the ones stored underwater. The loss of water means a partial drying out of the lining composite, which leads to lower adhesion. As a summary, the tests have proven that 3P resins are suitable to make high-quality short liner repairs, even underwater. 3P resins are developed and produced by Polinvent, a Hungarian company, which is continuously manufacturing these resins for the domestic and international markets. Polinvent. info@polinvent.com